Hi everyone. Thank you so much for joining the second session of E-LeetCoding. Our mentors today are going to be Nisa and Sai Krishna. So I think Nisa, you can go ahead and introduce yourself.
Hi everyone, I'm Nisa and I'll be going into my 3A term of CS in the fall, and I'm currently on a co-op term working at Meta, and it's really nice to be here with you guys today, and yeah, I look forward to meeting you.
And yeah, hi everyone. My name is Sai Krishna. You can call me Sai for short. I'm currently in my 2B term of CS, and I'm just happy to be here.
Great. Thank you so much. So our questions today, we have a lot of linked lists. So the first question, I think Nisa can go first, and she's going to go ahead with linked list cycle. And the second question, which is going to be led by Sai Krishna, is going to be middle of the linked list. So as usual, we just have spend the first 5 minutes to sort of review the question. We'll be putting up the question in the chat so you guys can open and sort of work along with everybody. So I think Lisa, you can start sharing your screen now.
I'm just sending the link in the chat, and let me know if you can see my screen. Can you see my screen?
Yep.
Okay, perfect. So I'll just read through the question. So you have a head, that's like the head of your linked list, and you want to see if the linked list has a cycle in it. So the way that they define a cycle is if there's a node in the linked list that can be reached again by continuously following the next pointer. So you just keep going down the list, and then like the next pointer for this node, like the -4, goes back to 2. So that's a cycle. So they have the pause, like the position, as like an internal thing, but you can't actually access that parameter. So it's just there just to illustrate it for us. So you just want to return true if there's a cycle in the linked list, and if it's not, then you just return false. So the first example is 3, 2, 0, -4, and then the -4 goes back to the 2, and then it just keeps going on. So this would output true because there is a cycle, and that's when the tail of the linked list connects to the first node, because we're starting at the 0 index. And then in the second example, same thing. The end of your linked list this time is going to the head of the linked list, and it just keeps repeating. And then in the last example, there's no cycle because you just have this one node and it doesn't go anywhere. It's not really connected to anything, and it doesn't go back to itself. So those are the examples that they gave us. So before we start going into it, can anyone think of like any other examples or like kind of tricky, edgy cases that we could like keep in mind before we start like coding? You can unmute yourselves or write in the chat whatever you feel comfortable with. If not, then I can like start just with some cases that I think might work. So you can just have like the example cases don't have an example where there's no cycle with a linked list that's more than one node. So I think that's an example we can keep in mind. So something like 3, 2, 1. So that would give you a false because there is no cycle. And then I think that's pretty much it. I don't think there is anything else that we really need to consider. And then, yeah, so does anyone have any ideas on how we can do this?
Could we use 2 pointers?
Mm-hmm.
So one, I think it's called the turtle and the hare algorithm or something like that,
Mm-hmm.
where there's a slow pointer and a fast pointer.
Mm-hmm.
One starts at they both start at the head,
Mm-hmm.
and then so the while the fast pointer is not none, and so like while fast that next is not none,
Mm-hmm.
you make slow equal next, and the fast one equal the next, and
Mm-hmm.
then if they ever because like if they ever meet, like if the because like once the once the slow and fast meet, that means that it's going in a cycle because Um, and then if they don't ever meet, and the fast reaches not like none, you would return false. Does that make sense? I don't know if I explained it correctly.
No, that was really good. I was just like taking notes as you were going through it. That was amazing. So I'm just writing down your last point. If they don't. So pretty much just, yeah, what you said sounded really good. So you have your 2 pointers, the slow pointer and then the fast pointer, and they both start at the same starting place, the head. And then like you said, you have like your fast pointer. So while your fast pointer is not null, you're going to make your slow pointer the next thing, like the next thing of the slow pointer, and your fast is going to be fast next. And then, so you know that if your slow and your fast pointers are equal, there is a cycle. But if they never meet, then there's no cycle. So pretty much, yeah, this sounds really good to me. Do you want to help me code it, or anyone can help?
Yeah, sure. Could we do it in Python?
Yeah, for sure. I'm a little bit rusty with Python though, just a warning.
Or I could tell you what to type if that
Mhm.
helps.
Oh, okay.
Um, so um, so we could do slow, comma, fast,
Mm-hmm.
equals head, comma, head.
Mm-hmm.
And then next line, while fast and while fast and fast dot next.
Mm-hmm. Is it 2 answers?
Sorry, no, just no, fast dot next. And then I think it's actually and. I've never used the ampersand in Python.
Oh, okay.
Yeah.
Uncommon.
Yep. And then next line, and then slow equals slow dot next.
Mm-hmm.
And fast equals fast dot next.
Mm-hmm.
And then if slow equals fast,
Mm-hmm.
colon, next line return true. Then outside the while loop return false.
Mm-hmm.
And then that's it. Because I think they have to capitalize the F and the T in true and false.
Oh, right there.
Yeah.
Thank
And
you.
then I think because like the fast it is moving at double the pace as the slow, so it'll eventually catch up or eventually reach the end of the linked list. I think that should work.
Awesome. Let's give it a try. This is really good. Let's submit it. Yeah, this is amazing. Thank you. And do you know what the runtime complexity could be?
I believe it goes to O of n because every node is to determine if it's a cycle. At every node has to be hit at least once.
Mm-hmm.
So
Awesome.
it would be O of n, right?
Yep, that's right. And then do you know what the space complexity of this is?
I'm not too familiar with space complexity.
Oh, okay. So the space complexity of this would just be constant because we're not really, like, we have our 2 new variables, which is fast and slow, but we're not doing anything else. Like, we're not making like 25 different variables. So that just makes it constant. It's because it's just 2, right? So that simplifies to a constant. But yeah, this was amazing. Thank you.
Thank you.
And does anyone have any questions about this? No? If not, I can stop sharing my screen. Do you want to go next slide, Krishna?
Yeah, absolutely. So the problem that I picked is LeetCode number 876. I'm going to put the link in the chat. Oh, there it is. Okay. So let's take a look at the problem. And I am going to start sharing my screen. By the way, I just want to let you guys know my roommate's shouting in the back for some reason. So if you can hear that, I'm sorry. Okay, so this is the problem. It's basically middle of the linked list. So we're given a linked list and we want to remove the, we're given the head of a singly linked list, and we want to return the middle node of the linked list. And if there's two middles, we want to return the second middle. So we can see in this example, 1, 2, 3, 4, 5. So obviously 3 is in the middle, so we're going to return 3. And then in this case, since 3 and 4 are both in the middle, we're going to return 4. So I'm just going to let you guys look at the problem for a minute and zoom in. Maybe not that much. Yeah, so I'll just give you guys until 7:45 to just look at it and think about it, and then we'll run through our solution. Okay, so feel free to unmute or type in the chat, but does anybody have any ideas on how we would solve this? Okay, so I see that Anu Priyam.
Yeah, just feel free to call me Anu. Yeah, so I was actually thinking similar to the last question, you have 2 pointers, one fast, one slow. If the fast pointer moves double the speed of the slow pointer, when it gets to the end, the slow pointer should be in the middle. And I was just trying some examples by hand. And I think when it gets to the end, the slow pointer will be on the second middle. So I might be wrong on that part, but I think this might be a valid approach.
Let's test it out. So what you're saying is, again, we're going to have 2 pointers.
Yeah.
And then there's going to be a slow pointer.
Yep.
And a fast pointer.
Yep.
That moves twice as fast as the slow pointer.
Yep.
And you're saying that when the fast gets to the end,
yep,
the slow is at the middle.
Right, because it moves half the speed.
Right. So do you want to help me code it?
Sure.
What language do you prefer?
I prefer Python, but yeah,
Sure.
yeah, should be fine.
Python
3. Python 3, yeah.
Okay. Sure. All right.
Right. So they both start at the head. So I think just like the last question, we can do. Yeah. Exactly. I think that should be good. And then I guess while the fast pointer. Yeah. So I think while the fast pointer doesn't equal the end of the list. So none, I think. I don't know if I should do fast.next doesn't equal none. I'm not sure about which, like, if that also makes sense.
Whatever you want to try.
Yeah, so we can do fast doesn't equal none and fast.next doesn't equal none. And then while this is, sorry, it's an and between the two.
Oh, sorry.
And so while this is happening, slow is equal to slow.next. And
I see David has a good point in chat. We'll get to that in a minute. So.
And fast equals to fast.next next.
Okay.
Yeah. And then at the end we can return slow. I don't think this is, I don't think this would be working yet. But I'm just trying to think if I missed something obvious.
Okay, so I'll let you sit on that for a minute. And David has a question in the chat. He asks, what if the list is length 1, right? So let's consider that case. I think this is how you do comment blocks, right? So what if list is length 1? In which case, let's say this is our list. What should the output be? David, you can feel free to unmute or type in chat.
If the list is if the list is length 1, the output should be that list.
So just 1, right?
Yeah.
Okay. So what do you think would happen if we run this function as it is with a list of length 1?
It will probably error out because fast.next is going to be not, well, it won't even run the, oh, maybe it will work.
Well, let's run the test case we have here, and then we'll pass in a list of length 1 and see what happens. So when we run this code, yeah,
Oh,
it works. And if we pass in a list of length 1, I'm going to run that again. It still works. So
yeah.
does someone want to tell me why it's going to work, even if
so
the list is 1?
I can explain. So when fast.next is equal to none, so like if fast first, like they both initialize to the head, and in
Correct.
like even from the get-go, fast.next is equal to none, so the while loop doesn't even run, and since slow equals 1, it'll just return.
Perfect.
Slow.
That's right. Does anyone have any other test cases they want to look at before we submit?
Could we do a list of length 2?
Yeah, I was actually going to suggest that. So let's say our list looks like this. What should the output be?
2.
2. Okay. And what do you think is going to happen when we run this code?
1 will be outputted.
1 will be outputted. Okay. Well, does anyone have any other idea what they think it would be, or do you guys agree that it will be 1? And again, feel free to unmute or just type in the chat. All right, so let's run it and see what happens. I'm going to get rid of these test cases for a minute. And when we run it, yep, the output is 2 and it worked. So why is the output going to be 2?
So so fast.next is going to be 2, fast is equal to 1, and so all the while loop conditions are satisfied, so it runs the while loop. Slow becomes 2 and fast becomes none, because it goes 2 to the right, and then the next time it runs the while loop, it realizes it's none and then returns slow, so it returns 2.
Perfect. So are there any other test cases you guys want to consider, or do you want to try submitting it? All right, let's submit. Going once, twice, thrice. Okay, let's see what happens. Yep, that's right. Good work, guys. And maybe next time we should coordinate a little bit better to see if we can make a problem that doesn't have the same method of solution. So yeah, as Anu pointed out in the beginning, the solution to this problem and Nisa's problem required the use of 2 pointers, and specifically having a fast and a slow pointer. So yeah, I guess that's the end of this problem. Anusha, how much time do we have left for this one?
We have about half an hour, so I think you had an extra question, right? I think we can go walk through that.
Yeah, so I did have a second question. ready. Okay. Got it. Which is this one right here. So we're going to do a medium question this time. We're given the head of a linked list, and we want to remove the nth node from the end of the list. And then we want to return the head of the linked list. So looking at the examples over here, we have the linked list is 1, 2, 3, 4, 5. And we want to remove the nth node, which in this case is 2, from the end of the list. So this is the first node at the end of the list. Then this is the second node at the end of the list. So we want to remove this node, and we want to return this linked list, which is 1, 2, 3, 5. So what we're going to do in this case is we're going to go to 3, and we're going to change its next to point to 5, as opposed to 4, and then we want to return the head, which is 1. So our output is going to be 1, 2, 3, 5. Oh, I'm so sorry, I didn't put the link in the chat. And then for this linked list, the head is 1, and we want to remove 1, n equals 1, which is the only item in the list. So we're going to return an empty linked list. And in this case, we're going to remove 1, which is the last item. So we're going to return just the head of the linked list. So I'm going to let you guys take a look at the problem for like a minute, and then we'll dive into the solution. Right, so it's 7:55 right now. If you can see down here, I'll wait till 7:56, and then we'll start. All right, so yeah, so does anybody have any idea on how we're going to solve this, or does anybody have any test cases? Anu again.
Yeah, I'm not sure if this is correct, but my initial thought is like you can first maybe count up how many nodes you have in a single pass through. So like, so in the first test case, there's 5 nodes, and n equals 2, and you want to remove 4. So maybe if you know there's 5 nodes, then you can start at the beginning again, count each way through, and right before you hit the when you go to the 3, you set next to the 5. I'm not sure if that's the right way to think about this, but that was my initial thought.
Sure. So yeah, I'm pretty sure that'll work. Let me write it down. So what you're saying is have an initial pass through.
Yeah.
Get a count on the number of nodes, and then loop through the second time.
Right.
And right before the nth node, so change the pointer.
Exactly. Yeah.
And then at the end, return the head.
Yeah, I didn't think about that, but yes.
Okay, so yeah, I'm pretty sure this will work. Do you know what the time complexity of this would be?
Right. So my initial thought is like, okay, what's like the I was trying to aim for an O of n algorithm. And I was like, okay, initial pass through is O of n. So that's going to be O of n. And if I'm just doing another pass through, then it's going to be O of n again, because I'm not doing any O of n, like I'm not doing any n squared work or anything. I'm just doing 2 pass throughs basically.
Yeah. And do you know what the space complexity of this would be? I mean, I know we didn't implement it yet, but
Right. So we're not storing any new variables, so it's just O1.
perfect. So yeah, let's try coding this. Python 3 again.
Yeah.
All right.
So I guess we need some kind of count variable. So count is equal to 0. And then so I guess while we need something to point to the head node. So maybe like a dummy, just a point. Yeah, dummy head to equals head. And then while dummy head doesn't equal none, count plus plus, or not plus, yeah, plus plus, and head, dummy head equals yeah, exactly. I think in Python it's not null, it's none, N-O-N. N-O-N-E, sorry.
My Python's not the best.
No worries, no worries. And then, so this should return, sorry, I'm just making sure. So it starts at 0, 1, 2, 3, 4. So in the first test case, the count would return a 4. And we want to get rid of the, sorry, I'm just having thoughts on how do I know what the nth node is?
It tells you the nth node right here. Like the nth node that you're supposed to remove, it tells you right here.
Right, but I need to calculate like how do I, like when I'm traversing through the list, how do I know it's the nth node? That's what I'm trying to figure out right now.
So with your solution, before I start talking, does anybody have any idea on how we would approach what Anu's talking about? You can type or unmute yourselves.
Would we make another pointer that is like at an interval of the length minus n away? Because
at an interval of the length. Sorry, say that one more time.
So we want to remove the nth pointer from the right. So we know first we determined how many and correct me if like I'm going on the wrong track, but we determined how long the list is, and to determine, so like for instance in this case we want to get the second node from the right, so we need a node that, so once we pass through again and we determine that we're at the end of the list, we need a node that's 2 nodes away at all times. So so to determine that, sorry, I had it for a second, but like as I was talking, I started to lose it. I'll mute myself again. Sorry.
Right.
So
sorry.
Go ahead.
Right. In this case, count is 5. We want to stop at when at the 3, right? So we actually want to do, and in this case, n is equal to 2, so we can actually just do count minus 2. So count minus 2 would get us, sorry, count minus n, is where we want to stop. And at that spot, we would want to make the head dot, like however we're incrementing dot next equal to itself dot next. That's how I would think of doing it. So you could skip entirely. So how I would do it is maybe have an count, like some kind of integer, like int n equals 0.
Okay, we can call it.
I'm not sure. I'm not sure if I should use another dummy head, or should I use an integer to do the incrementation. but I guess I'll need another one. So like dummy head equals head again. You can do like that. We'll have to traverse it somehow.
Right.
And then
Okay.
while
This is how we want it?
yeah, exactly. And then while dummy head doesn't not equal to none again. And then inside the while loop, we can do like I'm thinking maybe I need another count variable as well. Just because I want to keep I want to check if count equals n2, and if it does, you do whatever we need to, and then you break out of the while loop.
Well, what if instead of doing that, we just did a for loop up to n2? So, for example, in this case, we have.
Oh, sorry, that actually might be a. So yeah, I guess we don't even need a while loop. We just because we know how far we're going. So maybe for. How do you while loop through a linked list in Python?
Well, I think we could do something like this, and correct me if my Python is wrong, but I think if we did this.
Yes.
Dummy head is equal to dummy head dot next.
Oh, right. Sorry, you're right. And at the end of this loop, we would know that dummy head is in the correct spot. So after this loop, we can just do dummy head dot next is equal to dummy head dot next.
Yep. Then?
Yeah, sorry, is that head or Ned at the?
Oh, my bad. I think I cut Ned.
And then return head.
Okay. Does anyone have any comments on this, or should we give it a run? Okay. Does anyone have any test cases they want to consider before we run this? Okay. Well, let's give it a run and see what happens. Okay.
So we got rid of the 5. So maybe it's so maybe we have to go 1 minus the range, like n2 minus 1. Because we're clearly going too far forward. Like instead of n2 stopping at 4, it's actually stopping at. Sorry, it's instead of stopping at 3, it's stopping at 4 and getting rid of the 5. So maybe this would work.
Let's see. Okay.
That's right. Fine. Now we just have to make sure it just wasn't this test case that we just fixed.
So let's do the provided test cases and see what happens first. We'll run this later, actually. Running the first test case, we have. Ooh.
Could we use a temporary to hold the next case temporarily, and then once we remove the node that we want to remove, then add that. So a temporary node to hold the next of the node that we're removing, and once we remove that node, put that back, make that the previous nodes next, if that makes sense. So make the temp the previous nodes next.
We could do that, but do you think that would fix this issue right here? Like, let's investigate why this issue is happening, right? So our test case in this case is this one right here, where our linked list is just 1, and we want to remove n equals 1, right? So when we pass this, let's see what happens. What's count going to be at this point right here?
1.
Okay. So we're saying count is equal to 1. And then dummy head is going to be equal to none, right? Then at this point,
Yeah.
then at this point, we're making dummy node equal to head again.
Yep.
And we're saying that n2 is equal to count minus n. So that's going to be equal to 0.
Oh, our range becomes -1.
Exactly.
So,
You could do a bit of a.
Sorry.
No, someone was going to say something. Go for it.
Can we just like add an if statement like around line 27, 28, and then say if
Okay.
count is equal to 1, then you just retain the empty list?
So like this.
Yeah.
Sure.
Wait.
Let's give it a run. Oh, sorry.
What
Did
did
you
you-
mean when count is equal to 1, return none?
Yeah.
Oh, that was my bad. Yeah. Sorry about that. Okay. Okay, so that's good for now. Let's see what happens when we do the next case. What do you guys think is going to happen when we run the case 1, 2, 1? So this one right here. Do you guys think it's going to work? Let's run it and find out. Okay. So that case did work. Are there any test cases you guys want to test before we submit? Well, in this test case, we're removing n equals 1. So yeah, sorry, David, go on.
Could you try the? Actually, sorry, no, sorry.
No, go for it. We'll try it. Okay.
Sorry,
So,
can you try the test case like 1, 2, and then the input is 2?
1, 2, and the input is 2. Got it. Okay. So you mean like this?
Yeah.
Okay. So why do you guys think? What do you think went wrong?
I think it's the same issue of the -1. I'm not 100% sure, but having thought about it, I think the count is going to equal 2, and then you do count minus n, so 2 minus 2 is 0, and then you do 0 minus 1, which kind of breaks it. So there's some not trick, but we're missing maybe an easier way to do this.
Sorry. Would it make sense to use 2 pointers in this question?
Yeah, we can explore that solution in 1 minute, but what if we did this instead? So instead of checking if count is equal to 0, or if count is equal to 1, we could check if n minus 1 is less than 0. And then in that case, what is it that we would return?
Well, you would return none, but I guess this doesn't solve the case of 1, 2, 2, right? That's the one we just ran into. Because in that scenario, the answer shouldn't be none. It should just be 2.
Right. So what if we did this? Sorry, my roommate's screaming in the background again. I don't know if you guys can hear that.
I guess if you have more input, maybe you don't want to just return head.next. I'm not sure. This could work, but I'm not sure.
So I think this might work because n minus 2, n2 minus 1 is going to equal something less than 0, only if we're trying to remove the first element, right?
Okay. Yeah.
Because n2 is equal to count minus n. So if something minus 1 is less than 0, that means the thing itself is equal to 0, right?
Right.
And n2 is only going to equal to 0 if count is equal to n. So that means we want to remove the first element. So
right. Okay, that actually makes sense.
When we want to remove the first element, if there's only one element, then we have only a single thing. So we want to return none. But when there's more than one element, we want to return whatever the next thing it's pointing to.
Right.
So let's give this a run and see what happens. Okay. And to make sure we didn't break anything, let's run our previous test cases again, which were 1, 2, 3, 4, 5, and 2, and then 1 and 1, and then 1, 2, 1. And somebody mentioned the application of 2 pointers, so we will visit that in 1 second. So yeah, let's submit this and then let's see what it says. I'm going to try to speed things up a little bit because we have 15 minutes left. Yeah, okay.
Oh, cool.
So that works. That's really good. So again, what do you think the time and space complexity of this is?
Well, I think just like before, you loop through everything once. Actually, no, I think I already answered. Like you loop through it once, it's O of n, and then you loop through it like maybe max n times again, so O of n again. So it should be O of n.
And then the space complexity?
Well, you don't have any dynamic, like you're not storing n of something. You're just using the original thing given to you, so it should be O of 1.
Yeah, that's correct. So somebody mentioned 2 pointers. Let's visit that approach. So does that person want to unmute and then tell me what they think the solution is? Anyone? Okay, so if not them, does anybody know how we could use 2 pointers in this question? Oh, did you say it's a dynamic programming approach? No, it's not a dynamic programming approach. Somebody, to the person who typed that, somebody mentioned that maybe they could use 2 pointers for the solution. So let's see if we can solve this with 2 pointers. I'm just gonna give you guys a little bit, and otherwise I'm gonna say what I think the solution is. Okay, so yeah, the optimal solution for this is actually a 2-pointer approach. So whoever said that, Good job, you got that right. Let's look at how we can use 2 pointers for this though.
Sorry, I just have a thought about the 2 pointers.
Sure.
So before, when it was moving at double the speed, we got to halfway. So like we somehow have to get it so when it's at the end of the list, our first pointer is at n. Is that the idea for the 2 pointers?
Something like that. Not exactly though.
Okay.
Not exactly. So here's how we're going to do it. Can you guys see Microsoft Paint open? Okay, awesome. So let's say basically there's a hall, okay, that is 10 meters long. Okay, and let's say there's one person who their stride length is 2 meters long. And then you have another person whose stride length is 1 meter long. Sorry for the horrible drawing. So when the first person, and let's say they take a step at the same time. So when the first person takes their first step, they're at 1 meter, while the second person is at 2 meters. Then when the second person is at 2 meters, the first person is at 2 meters, the second person is at 4 meters, right? So for every 1 meter the first person travels, the second person travels 2 meters. Correct? Now let's change this up a little bit and say we have 2 people. I'm just going to draw them as circles now, too lazy to me. So that's person A and that's person B. And let's say their stride length is both 1 meter. Okay, except in this case, let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, cool. So let's say that the second person is right here and the first person is right here. And now they take steps together. All right. So when the first person takes 1 step forward, they're over here. And when the second person takes 1 step forward, they're over here. What's the distance between them in this case? 2 units. Perfect. So now when this person takes a step here and this person takes a step here, what's their distance?
2.
Oh,
2 units still, right? And now it doesn't have to be 2. So let's say we start in this case where this person is 1, 2, 3, 4. That's 4, right? 1, 2, 3, 4. Yeah, 4 units in front, right? So when this person takes their first step and then this person takes their first step, they're 4 units apart, right? And now when they take their next step and this guy takes his next step, they're still 4 units apart. So that is the hint I'm going to give you guys. And that is somewhat similar. We're going to use this to go towards our solution. So
Right.
give that hint. Does anybody have any idea?
Yeah, so I have an idea. So basically, for what you just gave, if the second pointer starts n distance away, when the first pointer is at the end, you end up with the first pointer being n distance away, which is the element you want to remove.
Exactly.
Or sorry,
and,
yeah.
Yeah, exactly. And David, you put the same thing in chat. Don't worry, I saw you. Good job to both of you.
That's what I was. Oh, sorry.
Yeah, no worries. So yeah, good job, David and Anu. So let's try coding this then. I switched to C# because I'm comfortable with C#, but since you guys got it, let's try doing it in Python again. All right, how are we doing this?
I guess
Any ideas?
yeah. So I guess they both start at the head node. So slow. I guess you could call it behind and ahead. And then they both start at the head node, and then I guess you have to worry about edge cases, like there isn't too many elements in the node, but the general idea is like you increment head n times, like head is equal to head.next, you do it n times. I think, Python might already do n-1 when you put n.
Okay.
Right, so you do that n times, and then you have to start, then you increment them both at the same time. So while ahead doesn't equal none, increment both. Right, and then at the end, I guess you have to remove. Sorry, now I'm just confused because I think you want to actually end up behind. You want to go to n-1. I think your initial n-1 was correct because you don't want to get to the spot you want to remove. You want to go one behind the spot you want to remove and switch.
So in that case, shouldn't it be n+1 because you want the ahead one more ahead?
Oh, sorry, you're right. Actually, yeah, I think that also works. Yeah. Right. Okay, and then at the end you can do behind.next equals behind.next next, and then return head.
Okay. So like this.
Right, but now all you have to worry about is edge cases. So I think one of the assumptions we made in the first loop is that there's at least n+1 elements, but that might not exist. So we'll have to deal with that somehow. I'm not 100% sure how we should deal with it.
Let's give this a run and see what happens. Yeah. So if I were to get rid of all this nonsense for a second. Our very trivial case is passed. Excellent. And now, what the hell? And now, the case we considered after that was when the linked list had one element and we were removing that one element. So let's see what happens.
So right, so this is the scenario where you end up with the issue there.
So how are we going to fix it?
I guess if you check before you increment that ahead doesn't equal none, because the reason this is happening is ahead equals none, and then you do none.next, which is not allowed. So if you do like inside the, I guess there's the base case is like, the base case.
All right, so we're running out of time. We have like about 4 minutes left. So I'm going to take over and I'm going to present you guys my solution, which uses this method of solution. I'm going to do it in C# because I'm just comfortable with C#. But you guys should understand what's going on. So basically, the two-pointer method was correct, but there's another method associated with two pointers. So do you guys remember how for the previous question, we did a fast pointer and a slow pointer? And then for this method, we're trying to keep two pointers that are like equally distant. So we called it an ahead and a behind pointer. So another technique that's commonly used is to make a dummy head, which is what we're going to do. So the dummy head doesn't necessarily have to point to the head. It can be anything, right? Sorry, the dummy head does not have to be a duplicate of the head. It can be anything. So here's how we're going to do this. We're going to first create our first list node. I'm just calling it A. So this is going to be our first pointer. And then we're going to throw in a lucky number. And then we're going to create our second pointer, which is, I'm going to call it B. And then we're going to throw in the same number because I think the other lucky number is inappropriate for right now. So we're going to use that same technique from before, where we're going to keep things equidistant. We're going to make the list, let's move B ahead. So we're going to put B and n units apart from A. So for I is equal to 0, I is less than n, I plus plus. If you guys notice any errors with like my typing, just let me know. B dot next. So what this is going to do is that it's going to put B an n number of units ahead of A, right? And then we're going to do the same thing we did in the Python solution, where we're going to do while B dot next is not equal to null, A is equal to A dot next, and B is equal to B dot next. Whoops. And then there in a minute. So at this point, we have A, and A is right before the node we want to remove. So we're going to do A dot next is equal to A dot next dot next. And then we're going to return head. And now we want to look at the edge case that I think Anu brought it up, where we want to remove, was it the first item or yeah, I think it was the first item in the list. So yeah, you are correct. That is an edge case. But since over here we made a list node that is pointing to the head, that is before the head, that basically fixes this problem for us. So essentially what's happening is that we had our head and we had the remaining nodes, let's say they're going this way. And we're like moving B and N units, we're making B and A be N units apart. So let's say like A is over here and B is over here and they're N units apart. And they're like moving down together so that when B reaches the end, A reaches like right before the node you want to remove it. So then just change this next instead of here to like here. I could draw it out to make it more evident, but I think you guys get it now. However, the edge case is what if you want to remove the head, right? What we've done here is basically we said, okay, this is the head. That's cool. We're going to make a new pointer here and make the next of this pointer equal the head, which is basically what's going to fix all of that, because now that n+1 case is fine because we do have an n+1 number of elements, right? So we just need a quick if statement. That's going to be if a dot next equals head, return head dot next. Because basically what's going on is that if a dot next is equal to head, so this is the case where we want to remove the head, right? Then we're just going to return the next item. Otherwise, this will be your standard solution. This will be your standard procedure. So if we try running this, I'm going to be so embarrassed if this doesn't work. All right. And before I submit this, does anybody have any questions, any test cases they want to try? Okay, so, oh shoot, we're over time. Please work, thank you. And yeah, so space complexity, time complexity, anyone?
Same as before. Well, you're only adding 2 new things, so that's O of 1, because there's always going to be 2 new things. Space complexity, correct. You're only doing 1 run through, so O of n. So O of 1 and O of n are the 2.
Correct. And the first solution that we got, the first Python solution that worked, how does the complexity of this compare to that?
I guess in terms of time complexity, they're the same. But in terms of like constant factors, like this is better because that one you have to go through it twice. While this one, I guess you would just have the same 2 pointers. Exactly. So you're going to save like a quarter of a millisecond or something on. It's just going to be a little bit faster. And yeah, so that's this question. I hope you guys enjoyed both of them. And yeah, that's it from me. So Anusha, if you want to take it away.
Great, thank you so much. Okay, so I hope you all enjoyed the questions that we did today. I think doing a lot of linked lists was quite fun today. And I hope to see you all next week for the 3rd session of E-LeetCoding. Thank you again for joining. Hope you all enjoyed it.